guys, welcome back. So what we're looking at today is 5.9. Can you get to the point 2? So let's go ahead and jump right in. All right, so for this first part, we're matching the name of the figure with its geometric definition. So we are going to look at 3, 5, and 8. So on 3, all of the sides of this quadrilateral are the same length. So for this one, a rhombus has the key feature of all of its sides are the same length, and it's a quadrilateral. So 3 is F. Now, for number 5, this quadrilateral has 4 right angles. Now, while you may be saying a square has 4 right angles, there's also a rectangle that has 4 right angles. And a square would need to also have 4 congruent sides. So this one is E. And then the last one I'm going to do with you is number 8. Only 2 sides of this triangle are the same length. So we have 4 different kinds of triangles up here. We have isosceles, equilateral, scalene, and right. Right has to do with the kind of angle it has. Scalene, equilateral, and isosceles are all about the side lengths. So equilateral means they're all the same. Scalene means none. And isosceles means 2 sides are the same length. So A. All right. The next section is solving systems of equations by elimination. Elimination is your key word for this lesson, elimination. So solve each system of equations using elimination of a variable. So in order to do this, we have to have the same coefficient on the same variable. So if we look at number 9, we have 2x and we have 2x in each of the equations. So that means we can subtract these. So if we subtract 2x minus 2x is going to cancel out. Y minus 2y is going to give us a negative y equals 3 minus 2 is 1. Well, we never leave our variable with a negative, so divide by negative 1. So y equals 1. Now, just like before, once you find what one value is, you have to find the other value. So we're going to plug 1 in for y into one of the equations. I'm going to put it in the first one. So 2x plus 1 equals 3. We subtract the 1. We have 2x equals 2. Divide by 2, so x equals 1. So our answer is 1, negative 1. Whoops, actually I did that wrong. Sorry, I wrote the wrong thing down for what y equals. That's my bad. So, not 1. This needs to be a negative 1, which changes what this equals. So, it will actually be minus 1, so we'll add 1 over. I apologize for that. So we end up with 4. 4 divided by 2 equals 2. So our solution is 2, negative 1. Remember, we always want to have our solutions as an ordered pair, not as just y equals and x equals. All right, the next one we're going to do together is number 12. So notice none of the coefficients are the same, which means we have to multiply one of our equations that we have the same. So I'm going to cancel my x's, so I'm going to multiply this whole bottom equation by 3. So now I have 3x plus 5y equals negative 1, and 3x plus 6y equals negative 3. We're going to subtract them because, once again, our signs are the same. So 3 minus 3, that cancels. 5 minus 6 is going to be a negative y equals negative 1 minus negative 3. So remember, you have to be super careful with that. It's really adding. So it gives us 2. So we divide by negative 1. And we end up with y equals 2. Negative 2. Careful, don't drop your negatives like I keep doing for some reason. So we end up with y equals negative 2. Now we have to plug that back into one of the equations to figure out what x is. So I'm going to do it into the original second equation. So x plus 2 times negative 2 equals negative 1. So x minus 4 equals negative 1. We add the 4 over. So we end up with x equals negative 1 plus 4 is 3. So our solution is 3, -2. Okay, so this is how we use elimination to solve these. So sometimes you may have to multiply both equations in order to be able to solve. Other times you may just have to multiply one. Other times it may work to just right off the bat subtract. So it just kind of depends on the problem. All right, the last section, identifying functions. For each graph, determine if the relationship represents a function. If it is a function, write yes. If it's not a function, explain why it's not. So in order for a graph to be a function, it has to be one-to-one, which means for every x value, there can only be one y value. So if we look at number 17, for each of our x values, do we only have one y value? Yeah, we do. So this is, yes, a function. For 18, for each of our x values, do we only have one y value? No. This would not pass the vertical line test. So the vertical line test is where you can take any vertical line and move it along the graph. And if it touches in more than one place at any given moment, then it is not a function. So in this case, the whole entire thing is not a function. In the case of up here, 16, notice we've got one little point right there, and it also exists here. So this would also be no. But here, where it's an open circle and a closed circle, it doesn't actually exist where the open circle is. So this one would actually be yes, even though at first glance it looks like it's in two places at once, but it's not actually because the one circle is open. Okay, so you're just determining whether or not it represents a function. If you guys have any questions, feel free to ask. Have a great day.